So this is a topic number 2, discussion problem week number 1, which is about chemical formula. Write formulas for ionic compound formed between, and there are species sure. So ionic compound is essentially there is a cation and there is an anion, and you have to figure out which one would prefer to be cation, which is losing electron, to be a cation, which one like to accept the electron to be a negative ion. And then this is an example. And this answer is actually can be found from here, shown up in the periodic table. So let's look at the first example with sodium. Sodium is shown up here, and the bromine is shown up here, right? And then you recall, this is what is called the noble gas column, which is satisfying the octet rule, and they want to be essentially the same electron configuration, same number of electron in the outer shell, just as a noble gas. So as far as the nitrogen is concerned, they prefer to be they prefer to lose a one electron. So therefore, sodium, not nitrogen, it's a sodium, Na, would like to lose electron, become sodium plus, and losing electrons. And whereas bromine would like to accept the electron and then became bromine minus. And it is a win-win situation. By losing electron, they became sodium plus, which is the same electron configuration as the neon. Right? This is same as a neon electron configuration. Bromine, by having one extra electron, your electron configuration is same as a krypton. So they are the one that prefer to be formed of species right there. So it will be a one-to-one correspondence. So therefore, answer for A will be sodium bromide. It's 1-and-1 answer. So that's here. If you look at the potassium, which is shown up here, so potassium therefore is potassium plus, and the iodine, which is shown up here, so it's the iodine minus. So therefore, I guess answer B is potassium iodide. So that will be answer. What about barium? So barium is here, and then the oxygen is here. So as far as an oxygen, they wants to be, because they are located in the 6th column, they like to have normally they like to have be like oxygen 2 minus, and this is a barium 2 plus. They wants to be because they are in the 2nd column, and so therefore, by losing 2 electron and acquiring 2 electron, it is a one-to-one correspondence. So therefore, the number C will be BAO is the answer. Okay, so let's look at the number 4, which is a different case. So let's look at the case of the magnesium. So magnesium is shown up here. So we know magnesium wants to magnesium 2 plus. So if I write it, the equation just like I write it before, Mg likes to be Mg 2 plus, and 2 electrons are coming out from there. Okay. But what about the bromine? And the bromine, we know they want to take 1 electron, take bromine minus. So it takes 2 bromine minus to neutralize 1 Mg2 plus ion. So what they need to do is, okay, I think the 2 electrons. So you need to do 2 electrons. You need to add them up. Now the 2 electron and 2 electrons are gone. And so therefore you need Mg2Br. That will be Mgbr2 is a compound that you're going to form in there. So therefore, the notation, the ionic compound that we use is magnesium bromide. It takes two bromine bromine minus ion to neutralize Mg2 plus, so that's why you write this way. What about the barium? Here, barium and the barium fluoride. This is the same thing. The barium 2 plus, fluorine is F minus, and it takes two F minus to neutralize positive 2 charges. So therefore, if you add them together, you need 2 of them. So therefore, that's a barium F2. Okay, so therefore, answer for E is BaF2. So it's a concept about ionic compound, and that how much, what's the number that you will need. Okay, so